Good morning, dear students. Good morning, all of you. So, this is a video of class 11, and in this video, we are actually going to talk about the electronic displacement in a covalent bond. First of all, you have to understand that there are different types of covalent bond. Earlier, you have read in class 10 single bond, double bond, triple bond. Okay, then how the electronic displacement will take place in covalent bond. And for that one we will study about the inductive effect. First of all, you have to understand that if I have some element, suppose I have taken the example of HH, two same element. So two same element, one electron is for this hydrogen, okay, and one electron is for this hydrogen. If there are same element, there is not the issue. You will find that the electron, the hydrogen or this electron pair will be in between. It will not go anywhere. Means this hydrogen will not pull this electron towards itself, and this hydrogen also will not pull this electron toward itself. That means the electron pair will be in middle, will be in between that one. Okay, but if I will take an example of HCl, one of the polar molecule, so what will you see? HCl, you know, one electron, two, three, four, five, six, seven, and one hydrogen, its electron. Now you also know this chlorine is more electron, more electronegative. So it will try to pull this one toward itself. So chlorine will become chlorine will become electronegative, but this one will become electropositive, and for that electropositive we are representing it by the delta positive. Okay now, so this is you have to understand. And due to that, electronegative is there, electron pulled by that chlorine towards itself and creating one of the positive charge on the hydrogen on the nearby its element. So that effect would be the inductive effect. So here we will actually talk about the inductive effect. There are two types of inductive effect. One is positive inductive effect and one is negative inductive effect. Okay now, so there are two types of positive inductive effect, and what is written over there you also have to focus that one. Here you had seen that we have talked about the polar molecules, polar compounds. So that means one should be electronegative, and what would be the commonly electronegative? It should be the halogen. Fluorine is the most electronegative, so we can take the example of fluorine also, but most probably we are taking chlorine. Okay now, bromine also we can take. So you have understood, and this inductive effect is the permanent effect. Okay now, permanent effect, and this will take place only in the single bond. This will take place only in the single bond, and if there is a single bond, then this one is called as a sigma bond. Okay now, that bond which is formed by actually sharing of two electrons, that will form the single bond, and single bonds means sigma electrons. Okay now, so everything you have understood. Here the explanation is given that whenever an electron withdrawing atom such as halogen, okay, or a group such as nitro group is attached to the end of the carbon chain, the sigma electrons will be attracted towards the more electronegative. Okay now, and creating a small positive charge on the nearby element. So this is the thing. Now you can see here the second slide. This type of displacement of sigma electrons every time occurs in a saturated carbon. Okay na, saturated carbon in single bond. I have told earlier there are two types of inductive effect: positive eye effect, negative eye effect. When there would be the positive effect, we will call, and when there we will be the negative eye effect will be called, we will actually see that one. Okay dear student, so here we will discuss about the types of inductive effect, and there are two types of inductive effect. First one is positive eye effect, okay, and second one would be the negative I effect. Okay now, so you can see this one here. I have written these two. Okay, so what we will see, that if there are some chain C C C, and here you will see that X means halogen would be there, and X can be anything: fluorine, chlorine, bromine, iodine. Okay, or in place of this X, some of the group can also be there. Okay now, some of the functional group will also be there, but it will be present along with the ring structure. Okay now, in this structure, in the long straight chain, we can take these FCl, PR or I. Okay now? So we believe that this one is a system, this one is a system, and this one is a group. Okay now, first case we have written this one. Okay, now second case, we are actually again we are writing this one C C C, and here X, and again this one is system, again this one is group. Okay now why I have written till 3 carbon only? Why I have written 3 carbon? Why I have not written 5 carbon? Why I have not written only 1 carbon? There is some rule, and that is, okay, so we can say that this is a rule that actually the inductive effect, positive I effect, will die down after the 3 carbon. Means you know that this one would be del negative, because I have told you that electronegative will pull the electron towards itself, and it will become electronegative, and this C will have some charges in the sense of positive charges, smaller charges. Now this smaller charge will further increases, and 2 delta smaller charge as compared to this, and this will have more smaller charge, and this effect will become negligible. So I am not going to write C4. You have understood? This one is electronegative. If this is electronegative, in respect of that, it will become electropositive. Okay now, if all the electron will migrate towards X, then it will automatically become electropositive. This is having some electropositive. This one will smaller than this one, and ultimately it will die down. Same thing would be happen with this one. So why I am going to tell the positive I effect, and why I am going to tell the negative I effect? You should see. If there are more electronegative, negative, this one, if X is more electronegative, okay na, if X is more electronegative than system, if X is more electronegative than system, then it will called as negative I effect. But if your X is less electronegative than system, then this is positive I effect. Okay na, positive I effect. This one is negative I effect. So it depends upon the group, what group you have. Okay na, someone is electron withdrawing group, someone is electron donating group. What does it mean? It means that electron donating group means it will give the electron to something, and if electron withdrawing group, that means it will take electron from some of the system. If suppose I will actually write this one, you can see here I will make one ring. Suppose here I have made one of the ring, and here X is there, and in the second structure I have taken one of the ring, and where Y is there. this one, if it is an electron donating group, then what will happen? It will give its electron to this ring, but in this case, if it is electron withdrawing group, what it will do? It will withdraw the electron from the ring. Okay, now, so on that basis, we can also categorize the eye effect and the positive eye effect and the negative eye effect with this also. So we will discuss that one in the class. If I will write, then I will write one thing: all the functional group, whatever the functional group I have discussed in the class, all the functional groups are positive eye effect. All the functional groups are showing negative eye effect, but all the alkyl group will show positive eye effect. Of now, if in this one, if I will connect with CS3, then you cannot tell easily. CS3 is a alkyl group, so positive eye effect will be shown in this case. If I will write here any of the functional group OH, the negative eye effect will be shown. So this one we have discussed now. Okay, thank you.